In this video, I'll teach you how to find exponential modulo for big numbers. So if they give big number like this, 11 power 37 mod 613, how we can find it? We are just going to use two simple concepts. One is uh, we are going to find the powers of 2 and then we are going to add it. How this basically works is using the formula a power m into a power n is a power m plus n. You would have read this in our school, right? So 37 and 19 and 157 is just simple example here. Whatever number it is, it can be written in the sum of powers of 2. So the same concept we are going to use here. So we are going to find the powers of 2 for 11 and 613. How we are going to do is see this simple formula x power n mod m. We are going to keep the x as same and then m as same. But then in place of n, which is 37, we are going to substitute powers of 2, 2, 4, 8 and so on and so forth. Till when we have to continue this is the n value which you're going to substitute should be less than the original, which is 37. So here as you can see, this 32, I'm stopping with 32. Why? Because 11 power 64. That 64 is greater than 37. I don't want this. So I'm going to find this. Now I'll tell you how we can find this because 11 power 32 is also difficult, right? So how we are going to do is we are going to follow these steps. First step is we are going to find for 11 square mod 600 or whatever number. Find the square of it. Now 121 is 11 square. Right? Now that number is less than 613. So if you find modulo for it, it will be same because the result is lesser than the modulo. Next step, what you're going to do is whatever answer we are getting, we are going to square it again. So here, as you can see, I am going to square this 121. 121 square is 11 power 4. Right? So I'm going to square this. And then whatever answer I'm getting here, I am going to divide it by the model. So here it's 613, right? So I'm going to divide it. And then I'm getting this answer, 23.88 and something. So what I have to do in the next step is subtract the integer part. We know this is the integer part and then this is the fractional part. I'm going to subtract the integer part. So I'm subtracting 23 here and then I'm left with the fractional part. And then I'm going to multiply it with the modulo. So I'm multiplying this fractional part with the modulo and then I'm getting 552. And then boom. This is the answer for 11.4 mod 613. Same step I'm going to follow. I'm going to square this answer. So what it exactly means is instead of finding 11 power 8 mod 613, I'm just finding this answer which is 11 power 4 mod 613 and then I'm just squaring it and then finding for 11 power 8. So I'm just squaring 542 and then same steps and then dividing it by 613, subtract the integer part which is 479 and then multiply the fractional part with modulo 137. Repeat it again. Square the answer 137 and then divide it by 613 and then subtract the integer part and then multiply fractional part with 613. I'm doing this till I'm getting 11 power 32. As I said before, I need to express it in the powers of 2, right? Now I got all the required values. So I can represent 11 power 37 as 11 power 32 into 11 power 4 into 11, right? So what is the answer for 11 power 32? This is the answer, 199. And then 11 power 4 is the answer is 542. And then 11 is 11. So I'm multiplying all of this. And then whatever result I'm getting, I am doing modulo with 613. So this is the answer I'll be getting. And then what I'm doing is I'm doing the same process again, dividing it by 613, subtracting the integer part, and multiplying with 613. The same steps can be followed for anything. Even if it is like 500 power 2000, just find 500 square. And then till what is the last power? 1024 is the last power, right? 2040 would be greater than 2000 and then just find just multiply all the values. What is the value for 500 power 1024 and then next one what it is now 512 and then we have to add this and then we have to multiply all of it and then we have to find the answer. So this is the basic idea how to find exponential modulo for big numbers. Thank you.